Hello everyone, I'm Erika Podest, scientist at NASA's Jet Propulsion Laboratory and part of the NISAR mission. My colleague Cathleen Jones and I have put together the following presentation focused on NISAR for flood mapping. NISAR is a satellite mission that contains two synthetic aperture radars or SAR sensors. One operates at L-band and the other one at S-band. The advantage of radar is that it can make observations of the Earth's surface day or night and regardless of clouds and most weather conditions. This mission is a collaboration between NASA and the Indian Space Research Organization, and it was launched on July 30th, 2025. NISAR covers all land and ice surfaces globally 2 times every 12 days. So between ascending and descending passes, the entire planet is covered every 12 days. And the spatial resolution is anywhere between 10 to 50 meters, depending on the acquisition mode. Now, these characteristics will enable capturing dynamic phenomena that occur randomly around the planet, anywhere from earthquakes and volcanic unrest to wildfires and inundation of wetlands. NISAR measurements at L-band are better suited for studying forested areas because L-band has a greater penetration capability through the vegetation canopy, while S-band data is better suited for lower biomass vegetation, for studies of lower biomass vegetation. NISAR will provide amplitude data, which is a measurement of the strength of the return signal and its orientation or polarimetry. And amplitude data is sensitive to water, to vegetation, to soil moisture, to biomass, to forest degradation, deforestation, etc. NISAR will also provide phase data, which can be used to do interferometry and which is relevant for studies related to surface displacement, surface movement, and surface disruption. So let's focus on flooding. And from a radar perspective, flooding is a permanent or temporary occurrence of a water surface. And this water surface can be either under a vegetation canopy, so it could be like a tall forest, an inundated forest, or short standing vegetation. The surface or water surface can also mean that it's a water body, but it does not have any standing vegetation. So that's referred to as open water. So basically radar is sensitive to inundated vegetation and to open water. And I want to briefly discuss the interaction of the radar signal with the land surface as related to flooded surfaces. So first of all, radar instruments imaging radars are side looking, so that they're looking sideways, they're not looking straight down. So the radar instrument sends a signal, and depending on the characteristics of the surface, the signal, obviously when it reaches the surface, it will disperse or be reflected. It can be in different directions, but it depends on the characteristics of the surface. And the radar sensor collects any part of the signal that is reflected back to the sensor. So if there is open water, for example, the surface is considered smooth. So a water body is a smooth surface, and the signal reflects away from the satellite. And therefore, these areas don't have any return, any of the signal does not return back to the satellite, and these areas then appear dark. Now, if there is some level of roughness, say on the water, because of wind, the signal will disperse, will scatter in different directions, and part of it will return to the satellite. And then finally, in cases where there is inundated vegetation, remember the signal penetrates through the vegetation canopy and it reaches the water underneath, the standing water. So that standing water is a smooth surface which causes the signal to reflect away from the satellite, but the tree trunks redirect all of that energy, or most of that energy, back toward the satellite. So these areas, wherever you have inundated vegetation, they appear very bright. And I'll show you how this looks. In the case of a specular reflector or open water, the signal is scattered away from the satellite and therefore no energy will return, or no signal will return to the radar sensor, and that area will appear dark. And so what we're seeing, or what you're seeing here, is an L-band mosaic of the Amazon basin from the SMAP radar. This was back in 2015. However, what I'm highlighting here with the yellow circle is the Amazon River, and note that it appears dark, so that is open water. Now, in the case of flooded vegetation, a large portion of the signal that is transmitted is received, and therefore these areas appear very bright. So the bottom line here is that when you use radar for flood mapping, you're either looking for a very dark signal or a very bright signal. And here you can see how well you can detect inundated vegetation. This is something you wouldn't be able to detect with optical, because optical is just seeing the top of the canopy. Radar is penetrating through the vegetation canopy, and it's able to detect standing water underneath the vegetation. It cannot determine how much water there is above the surface, just that there is standing water. So it can be a couple of centimeters or it could be a couple of meters. And the yellow circle highlights the inundated vegetation. And all of the white areas that you see are inundated vegetation along the Amazon. It's not always straightforward in terms of it being fully dark or fully bright. Sometimes you do have sources of confusion. So when you have windy conditions over water, for example, the water won't be fully dark, as you see on the HH image on the far left and on the VV image on the far right. So there'll be some level of roughness over water, and this will be similar to areas that have similar roughness on land. So say there's a tilled field. Tilled fields can look similar to water that has certain level of roughness. And so these are things that the user needs to account for in order to remove these sorts of confusions. And here we have an example of inundation. This is in the east coast of the United States. A large hurricane called Hurricane Matthew caused major flooding in this area in October 2016. And the two images, Sentinel-1 images, are before the event and shortly after the event. And note the orange areas that pop up along the coastline after the event. This indicates that these areas are inundated. And this is what a NISAR image over a wetland looks like. So this is over the Peace Athabasca Delta in Alberta, Canada. And the image on the top is a false color composite of the NISAR image. And the one on the bottom is a classification, which shows open water in light blue, herbaceous wetlands in dark blue, and shrub and forested wetlands in cyan. So what is the status of NISAR and how do you access the data? There's still some calibration issues that are being worked with the NISAR data. There will be a limited NISAR data release sometime in late February of this year, 2026. And then the fully calibrated entire data will be released in the next couple of months after that. All of the NISAR data will be available without cost through the Alaska Satellite Facility. And I wanted to bring to your attention the Opera platform, which stands for Observation Products for End Users from Remote Sensing Analysis. And this platform uses optical and radar data to generate 4 different products, as you can see listed here. And one of them includes surface water extent. The products are at resolutions up to 30 meter, and they're being developed anywhere from just North America to near global coverage. So Opera will be incorporating NISAR into its data stream. NISAR has developed algorithms for different science areas, including inundation detection. And this algorithm document is known as the Algorithm Theoretical Basis document. And it's also in the form of a Jupyter notebook, and it can be accessed through the GitHub link above. And now I will do a short flood demonstration with radar using Google Earth Engine. Thank you, and below is our contact information.